Hello everyone, welcome back to my channel IGNOU DNHE online classes. I am Dr. Aayushi Choudhary. Today we'll be studying a very important chapter of DNHE 2, which is Unit 5, Water Supply and Waste Disposal. This unit is very important from exam point of view, so prepare accordingly. Today we will study introduction of this unit, sources of water, water harvesting, urban drinking water supply systems, urban water supply programs, urban water disposal, water supply and sanitation programs in rural areas. Introduction. Over the past few decades, rapid industrialization and urbanization have placed immense pressure on natural resources, particularly water, and on waste disposal systems. With growing populations, the demand for clean water and efficient sanitation has increased dramatically. In this lecture, we will examine how societies manage these challenges through structured water supply systems and waste disposal mechanisms, and how these efforts contribute to environmental sanitation. Objectives. List the more prominent sources of water, explain how water can be harvested to meet the rapidly growing demand, describe the salient features concerning various water supply and waste disposal systems, outline the methods of purifying water and recycling waste, broadly examine the priorities and achievements of the ongoing water supply and sanitation programs, analyze the rational use of water and sanitation facilities, outline suggestions to enlist better community participation in water supply and sanitation programs. Sources of water. Water exists in multiple natural forms. Surface water includes rivers, lakes, ponds, and reservoirs. Groundwater stores in aquifers is tapped through wells and springs and is naturally filtered as it percolates through soil. Oceans and seas contain 97% of Earth's water, but this is saline and cannot be consumed directly. Other sources include glaciers, snow, and rainfall. Interestingly, only 1% of Earth's water is usable, fresh water, with most of it locked in glaciers and under hydrological cycle or water cycle. All water on Earth is constantly moving through the hydrological cycle. The hydrological cycle starts with evaporation. Every year, seawater and surface water from the earth is evaporated by the sun's warmth. When this eventually falls again as rain or snow, it falls on the land and sea in different proportions. A large proportion of this water received by the continents returns to the oceans. The portion which falls on the land eventually runs back into the sea, but in the meantime, those who have lived on the land where it falls have the benefit of it. Some of the water falling on the land runs off in streams, or it may be held in lakes or ponds. These plus the oceans constitute the Earth's surface waters. From these bodies or stationary reservoirs, water is evaporated, going back into the sky to form moisture laden clouds that eventually lose their water again to rain or snow. Groundwater protection. Groundwater lies beneath the Earth's surface, with its upper level known as the water table. Though generally clean, it interacts with surface water and it is vulnerable to pollution. Over extraction lowers the water table, sometimes causing land subsidence. Since deep aquifers take thousands of years to recharge, contamination can be nearly permanent. Protecting groundwater requires careful planning and sustainable use. Salinity factor. Excessive soil salinity arises from poor irrigation and drainage. Rainwater dissolves salts that accumulate in groundwater, and when the water table rises, salts move upward, concentrating at the surface. This creates saline soils unsuitable for crops. In coastal areas, over extraction of groundwater allows seawater intrusion, worsening contamination. Effective drainage and sustainable irrigation are necessary to prevent land degradation. Water scarcity. Historically, water was considered abundant, but today rapid population growth and industrial demands have made it scarce. Agriculture, mining, and urbanization require vast amounts of water, while pollution from untreated waste, fertilizers, and pesticides reduces quality. Clean water is increasingly difficult to secure, making conservation and rational use critical. Types of wells. Wells are traditional sources of groundwater. Shallow well is tap water above the first impervious layer and are highly vulnerable to contamination. Deep wells draw water from below this layer and are comparatively safer. Tube wells are a modern adaptation which are both safe and economical, though they require regular maintenance. Regional variations include step wells in Rajasthan and dug wells in the other parts of India. Protecting wells. To protect contamination, wells must be located away from latrines and rubbish heaps, lined with cement or stone, and covered at the top. A parapet wall and drainage system should be constructed to prevent seepage. Washing and bathing near wells must be prohibited, and hand pumps are recommended for safe water extraction. Disinfecting wells and drinking water. Disinfection involves calculating water volume by the well by the given formula, then calculating the bleaching powder needed. After that, preparing chlorine solution and mixing it thoroughly in the well. A contact period of at least 1 hour ensures safety. For household drinking water, bleaching powder can be used to prepare stock solutions, reducing risk for waterborne diseases such as cholera and typhoid. Rainwater harvesting. Rainwater harvesting is the collection and storage of rainwater from rooftops, catchments, and slopes. The advantages of rainwater harvesting are as follows. It helps in recharging the underground water. Water stored underground is less prone to pollution. It prevents soil erosion and flooding. It is inexpensive and simple technology. Improves groundwater quality by decreasing salinity. Negligible evaporation losses. Rainwater harvesting techniques. Rainwater can be harvested both at the domestic level as well as the community level. So let us now study about these water harvesting techniques. At the domestic level, rooftop harvesting is common, while at the community level, large catchments and village ponds are used. This is an inexpensive and eco-friendly method, and it is vital for sustainable water management. Domestic level. This is also known as rooftop rainwater harvesting. This technique of capturing and storing the rainfall utilizing the rooftops building, industrial and other housing complexes. Though rooftop water harvesting is a very old practice, but it has acquired more importance nowadays in our increasing water needs. Second is community level. Large catchment areas are used in rural areas for collection of surface runoff into village ponds and reservoirs by drainage pipes. Urban drinking water supply systems. Access to safe water and sanitation is a priority in developing countries like India, where many health problems such as diarrhea, dysentery, and cholera are waterborne. Rapid urbanization and industrialization necessitate centrally managed water supply systems to ensure safe drinking water. Fresh water contains dissolved materials, gases, and suspended particulate matter. A balance among these is essential for maintaining aquatic ecology. Any imbalance may render water unfit for human consumption and harm aquatic life. To provide potable water, it is necessary to purify surface water from rivers and other sources since groundwater alone cannot meet urban demand. Large-scale purification of water. Urban areas depend on large-scale purification systems since groundwater alone cannot meet demand. Purification methods include sedimentation, filtration, and chlorination. Sedimentation allows impurities to settle, filtration removes pathogens, and chlorination disinfects water. Advanced methods like ozonation and UV irradiation are also used, though they lack residual germicidal effects. Water quality standards. Standards ensure safe drinking water by monitoring microbiological pollutants, toxic substances like arsenic and lead, and acceptability factors such as taste and odor. Radioactive substances are also considered. These standards protect public health and guide urban water supply bodies. Urban Water Supply Program. Government initiatives include the Accelerated Urban Water Supply Program, Jawaharlal Nehru National Urban Renewal Mission, and Urban Infrastructure Development Scheme for small and medium towns. These programs are primarily for towns with low per capita water supply, drought prone areas, and regions affected by contamination from chemicals like fluoride and arsenic. Urban waste disposal methods. Waste refers to unwanted materials from homes, streets, commercial, industrial, and agricultural activities. It includes dust, ash, biodegradable matter, paper, rags, glass, and plastics. Prolonged accumulation can pose significant health hazards. Steps in waste disposal. First is storage. Waste, waste must be stored at its origin in dustbins with tight fitting lids made of galvanized metal or plastic. Second is collection. Ideal method is door to door collection, and in other cases, use public dustbins and mechanized vacuum suction vehicles. Third is disposal method. Disposal methods range from dumping and burial to sanitary landfills, incineration, and composting. Sanitary landfills are safer as waste is covered daily with soil, eliminating pathogens. Composting converts biodegradable waste into vulnerable fertilizer, while incineration is used for hazardous hospital waste. Sewerage systems and sewage treatment. Sewerage system. Sewage is wastewater containing solid and liquid excreta coming from houses, streets, commercial and industrial areas. Sewage is wastewater without human excreta. The sewerage system means collection and transportation of sewage for proper disposal in a compiled system. Both the sewage and storm water is carried, whereas in a separate system the surface water is not allowed to mix with sewers. The separate system is considered best. A sewerage water system consists of the following: sanitary fittings in household or establishment. The sanitary fittings of a household consist of water closet, wash basin, sink, urinal, etc. House drain. The sewage and wastewater from the sanitary fittings enters the house drain through soil pipes with a gradient towards the main drain. A vent pipe is usually connected to the house drain for escape of foul gases. Public drains or sewers. These collect sewage from several houses in various localities and transport it to a place of final disposal. Manholes and traps. Manholes are openings in the sewer system placed at frequent intervals and at bands and junctions of sewers for purposes of inspection, repair, and cleaning. Traps are devices designed to prevent foul gases entering the houses and to remove sand and grit from sewage. They are placed at various sites. Sewage treatment. In India, only about 50% of the urban population has proper drainage, while most rural residents still practice open defecation. This contaminates water sources and spreads diseases such as typhoid, dysentery, cholera, gastroenteritis, polio, and hepatitis. Stagnant water also encourages mosquito breeding, leading to malaria and yellow fever. Stages of sewage treatment. Primary treatment. It removes large solids from sewage. These are either burned or used as fertilizers. Secondary treatment. Effluent is filtered or aerated with activated sludge. This reduces solids but leaves organic matter, which can cause algal blooms in lakes, depleting oxygen and killing aquatic life. Tertiary treatment. Advanced chemical processes remove nitrogen and phosphorus. Chlorination, carbon filtration, or similar methods further purify water, making it safe for reuse and commercial purposes. Sewage disposal. Sewage disposal involves sewage purification by a process of stabilization by breaking down the organic matter to simple substances and to prevent further decomposition. The bacterial action of aerobic and anaerobic processes purifies the sewage system. Sometimes certain other methods of sewage disposal are also undertaken, like river outfall, sea outfall, sewage farming, oxidation ponds. Rural water supply and sanitation programs. In rural areas, programs like Swajal Dhara, Bharat Nirman, and the National Rural Water Supply Program aim to provide safe drinking water. The main goal of rural drinking water programs in India is to ensure adequate, safe, and sustainable water for drinking, cooking, and domestic needs. Solutions must be practical and inexpensive, yet experience shows that simply providing taps and latrines is insufficient. Parallel to water supply, sanitation programs have been introduced. The Central Rural Sanitation Program, which focused on constructing sanitary latrines to improve privacy, especially for women and overall health. Total Sanitation Campaign is adopting a demand driven approach. It emphasizes on awareness, community participation, and self help, with voluntary organization playing a vital role in promoting safe water, sanitation, and hygiene practices. Role of NGOs and case studies. NGOs play a vital role in awareness building and training. Case studies highlight women trained as hand pump mechanics in UP, the Swachh program in Rajasthan combating guinea worm disease, and youth clubs in West Bengal promoting hygiene. These examples show how community participation and empowerment strengthen water and sanitation initiatives. Water supply and waste disposal are fundamental to public health. Protecting groundwater, adopting rainwater harvesting, ensuring urban purification, and promoting rural sanitation programs are essential steps. Community participation, NGO involvement, and sustainable practices ensure that clean water and sanitation facilities reach all the sections of society. Rational use of water and effective waste management are also just technical solutions but social responsibilities. Here are some important questions from exam point of view from this unit. And also don't forget to solve the check your progress exercises given in the study material. In the next video, we will continue with Unit 6 Personal Hygiene.